Alrighty, hello. Alright, so this is going to be the lesson 4 video that you need to take that unit 4 quiz. So we're going to be talking about quotients of rational numbers. Remember that quotients is another way of saying division. Alright, so first we're going to talk about some rules for dividing negatives. Okay, if you ever have the same sign, you're going to have a positive number. Okay, so if I have negative 16 divided by negative 4, since both of these numbers are negative, they're the same sign, I'm going to have a positive 4. So I'm dividing my numbers and I'm going to have a positive number. Here's another way of showing that division. Right, I have negative 20 divided by negative 10. Since both of those negatives are the same, I'm going to have a positive 2. Okay, so if you have the same sign, you're going to get a positive number. So now if you have opposite signs, meaning one positive and one negative, your answer is going to be negative. So opposite signs means one positive and then one negative. Your answer is going to be negative. So negative 16 divided by 4 is going to give you negative 4. 20 divided by negative 10 is going to give you negative 2. Alright, so here we have some examples with parentheses and absolute value. So if I do what's inside the parentheses first, remember when we do PEMDAS, we have to do the math inside parentheses first. This negative is outside. If I have 21 divided by 7, I get 3. So I have this negative 3, which is just going to give me negative 3. Here I have a negative 21 divided by 7. So 21 divided by 7 I know is 3, and since my signs are opposite, it's going to be a negative 3. And remember that you can check these with a calculator. So if I were to type in negative 21, negative 21, and divide that by 7, I get negative 3. Alright, and last example here, again, same numbers, so 21 divided by 7 is still 3. Since I only have one negative sign, they're opposite, right? Positive and negative. My answer is going to be negative. The next thing we're going to talk about is absolute value. Okay, the absolute value, which are these bars around the number, makes, regardless of whatever number is inside of it, it's always going to make it positive. So absolute value will always make your number positive. Okay, so if I have a positive 21, well, that's just going to stay as a positive 21. Okay, and if I have a positive 7, that's just going to stay 7. So this is going to give me 3. Now remember, anything inside absolute value signs becomes positive. So this negative 21 will become positive 21 over 7, which is 3. So 21 is going to stay 21. This negative 7 is going to become positive because of those absolute value signs, which is going to give me positive 3. Alright, the next thing are some word problems that deal with negatives. Remember that in this unit, what we're doing is we're dealing with quotients, right? And quotients means that we're going to be dividing. So a huge hint with these word problems is you're probably going to want to choose the option that has division. This problem in particular says that a monsoon rainstorm changes the air temperature in a city by a total of negative 4 and 4/5 degrees throughout the night. If the storm lasted 8 hours, how much did the temperature change each hour? So it lasted 8 hours. I want to know how much it changed for every hour. And I know that the total change was this negative 4 and 4/5. Remember, we're dealing with quotients, which means we want to be dividing. So if I take negative 4 and 4/5 and divide it by 8, that's going to give us how much the temperature changed per hour. Now we don't have to actually divide this because the answer choices we have here are just telling us what math that we want to do. The first option is subtraction. Here with this weird looking fraction, that's division, addition, and multiplication. So I want to pick B because we are dividing. Alright, we're on more word problems. Remember that you can use a calculator for any of these. Okay, highly suggest using that calculator. A fundraising event ordered a 50-foot sub sandwich to sell. the length of the sub sandwich changed by negative 42 and 3/4 feet in 5 hours. If the length of the sub changed by an equal amount each hour, part A, so here we have part A, wants us to write an expression that can be used to calculate the amount of sub eaten each hour. Remember what we did before? I took that negative 42 and 3/4 and I divided it by 5. That's what we did on that last problem we just did. So that's part A. This is our expression. Part B is asking us to actually figure out how many feet of sub were eaten every hour. So that's actually taking this negative 42 and 3/4 and we're going to divide it by 5. But before I type this into my calculator, I want to make it a improper fraction. Okay, so to do that, remember you multiply denominator times your whole numbers. You want to do 4 times 42. And then I want to take that 168 and you want to add it to your numerator, so plus 3, which gives me 171. So I have 171 over 4, and it's negative. Okay, your negative still stays with it. I'm going to divide it by 5. So now this we can type into our calculator. So 171 divided by 4. And we're going to divide all of that by 5, which is going to give us negative 8.55. And if I convert it to a fraction, I could if I wanted to, but I think I'll just leave it as a decimal. But know that if you hit this button, it does convert it to a fraction for you, which means that 8.55 feet were eaten per hour. It's a lot of sub. All right, here's another one. Landon works at a cafe. He bakes 78 muffins and needs to place them into boxes for sale. Each box holds 6 muffins. Write an expression that can be used to calculate the number of boxes Landon will have. All right, so let's have this part A. Okay, so he bakes 78 total muffins and each box holds 6. So if I want to figure out how many boxes, remember we're talking about quotients, so we're dividing. Okay, so I need to divide these two numbers. So if I have 78 divided by 6. Part B is asking us to figure out how many boxes Landon's going to need, or how many he'll have once he divides all of these. So, whoops, pull up on our calculator. All right, I have 78 divided by 6, which tells me that he's going to use a total of 13 boxes here. 13 boxes. All right, terminating and repeating decimals. So a terminating decimal is a decimal that does not go on forever. Okay, so terminating means that it ends. Okay, so it doesn't go on forever. There's no repeating. There's no decimals that go on to infinity. It just stops. Okay, so here are some examples of terminating decimals. So 0.789, it ends. Now 0.3333. You might think that this is a repeating decimal because you're thinking, well, there's a pattern. However, there's no dots, right? There's no ellipses at the end, which means that this is a terminating decimal. It stops. Same thing with this one here, 0.56789. Yes, there's a lot of decimals. However, they end. They end at the 9. Repeating decimals are where one or more of those numbers will repeat forever, and it must have a pattern. Okay, so here's that 0.333 like from above, but notice there's this ellipses, or those 3 dots at the end, which tell you that this 3 is going to go on forever and ever and ever and never end. The bar above the 5 and the 6 means that the 5 and the 6 will repeat forever. So this decimal is going to be 0.56, 56, 56, 56, forever and ever. Now here, notice that the bar is only above the 1, 3, and 6, which means that the decimals that we'll be repeating are the 1, 3, and 6, like this, okay? So the 4-9, since it's not underneath that bar, the 4-9 does not repeat. Right, so here's some examples, and we're going to determine if they're terminating or repeating. Now, what we're going to do for these is we're just going to divide all of these on a calculator and see what the calculator tells us. Okay, if I have 1 divided by 11. Oops. If I look here, I have 0 0.9, sorry, 0.0909090991. Now this 1 right here is being rounded from before, which means that if this 1 divided by 11 is going to give me, whoops, 0.0909 forever repeating, this is a repeating decimal. Let's look at 4 divided by 25. I get 0.16. That's it. It stops. It ends, right? So since I get 0.16, this is a terminating decimal. It ends. Now this one here, you might be thinking, what is this? Because there's this 2 minus 5 in the bottom. What we're going to do is just subtract those first. Okay, so I have 3 over. And then I have 2 minus 5, which gives me negative 3, which means I'm going to have 3 over negative 3, which is negative 1. This is negative 3, which gives negative 1. And negative 1 technically isn't a decimal, but it has a point 0 at the end, which stops. So this is terminating. Now, if you wanted to, you could type this into the calculator how it is. And if you do that, you'd have 3 over 2 minus 5, which still gives you the same thing. Okay, so we can do that for this example on 4, where I have 5 minus 9. Oops. This one, let's put it in parentheses, so 5 minus 9. So that way when I divide it, 5 minus 9 stays in my numerator over 9. So this is negative 0.4 repeating, right? The 4 is going on forever and ever. It's not ending. So this gave me negative 0.4 that goes on forever. So this is a repeating. Okay, so remember for these ones, just pop them into a calculator to double check. Alright, and then the last thing I wanted to go over is a somewhat tricky checkpoint question. So it's saying that Ava used the following equation in order to solve the math problem involving integers, which are positive and negative numbers. And it says that negative h over negative k equals j. So so h is negative and k is negative. So if the equation Ava used is correct, which of the following equations must also be correct? Select all that apply. Okay. Well, if k is negative and h is positive, right, they're opposite, which means that j should be negative. So that one's correct. Here, I have 2 negatives, right? These are the same sign, which means I should get a positive j. And since j is negative, that's not a good option. Here, negative, I think this is supposed to be a positive k. So this should say negative j equals negative h over k, which would be correct, right? Because I have opposite signs, which means that my answer is going to be negative. And this last one, D, this is what we're used to seeing, right? 2 positives being divided, which will give us a positive one. So there's only one wrong answer choice, which is the one where you have these 3 negatives. That one does not work. Alright, so the quiz code for this Unit 4 quiz is pancakes, spelled exactly like that. You can go ahead and start the quiz now that you have that quiz code. If you need help or have other questions on anything, please let me know. Other than that, have a wonderful rest of your day.